Hello and good morning. Please, can you hear me?
We can hear you, sir.
Hear me?
Yes, please, we can hear you.
Hello? Hello? Can you hear me?
Yes, we can hear you.
Sir, we can hear you, sir.
Okay. Thank you. We did before I continue. Okay, if there are no questions, what I'm going to do is I'm going to review what we've done so far in matrices and then end with the last method that you are supposed to know basically, and then we will see if there's time. I'll introduce series and sequence. If not, we'll push it to very next week or so.
Okay, sir.
Next week or next 2 weeks. I hear next week. So I'm going to share my PowerPoint. I'll start from the PowerPoint and then come to the Excel document. Okay, so first of all, I need to review this.
Hello, sir. Hello, sir.
Why I have
Sir, good
to
morning once again.
cut the
Sir, please.
questions online, the
Sir,
questions on
please.
matrices online. Good morning.
Sir, please, your line is breaking. It seems your network is not strong enough.
Go ahead.
Please, I'm saying your line is
Go ahead,
breaking.
Stephen, is that you?
No, Solomon.
The line is Solomon.
Yes, your line is.
I changed the network a few minutes ago. Okay, let me change it. Let me change it again and see. Is it?
It's better now. It's better now.
Okay. Okay, so I'm saying that on the questions on the LMS, there are questions that is asking you to add matrices, multiply them, and also to be able to solve systems of equations like this. Okay, that's the first part. And then the second part, you're supposed to know how to find the determinant of 2 by 2, 3 by 3, and also to solve a relationship like this. By the final part, you are supposed to, you are solving a system of equation using 3 methods. The first method is the determinant method, which we have done. And then the inverse method, I think we've also done part of it. Now, this one we haven't done, Gaussian elimination and substitution method. So today, that is what I want to introduce you to. So you need to solve these 2 equations using these 3 methods, just to make sure everybody understands the 3 methods and can do it. And then the last one, question 5, you are supposed to use Gaussian elimination here, and here you are supposed to use Kramer method here. So based on this, that is why I want to go over what we've done so far with respect to the Kramer method. So I'm going to briefly go through the pattern. So this is explaining how to find determinant of a 3 by 3 matrix, but I want to start with from here. So like we said, we can find determinants of matrices, and if the determinants are being added, we can find the determinant of the individual matrices. There are certain things that is accepted, there are certain things that is not accepted. The first one, addition, we are told that if you are asked to add 2 matrices, A and B, and find their determinant, it's not equal to finding the determinant of the individual matrices and adding. That is the first property. The second one, I always ask a question in our MCQs on this, that when you are given, you are supposed to find the determinant of a matrix multiplied by a constant, and the constant, if you know what the constant is, then we are saying that take that constant, raise it to the dimension of the matrix. The n here stands for the dimension. So if you know that it's 3 by 3, n is 3. If it is 4 by 4, n is 4. And then multiply by the determinant of the matrix itself. So this is the second property of determinant. Now, again, when you have 2 matrices and they are multiplying, and you are asked to find the determinant of the product of the matrices, then it is the same as finding the determinant of the individual matrices and then multiplying them. The last property here is that when you transpose a matrix and you find the determinant, it's the same as the determinant of the original matrix. So these are some beautiful properties that we know we can use in matrices. Now, when you come to the next slide, we also get to realize that when you're asked to find the inverse of a matrix, and find its determinant, it can be written as 1 over the determinant of the matrix. So instead of finding a matrix, find its inverse, then find the determinant, just find the determinant and find the reciprocal of it. Okay. The 6th property is that false property. Sorry, the second property, number 2. What it's saying here is that when you have 2 matrices, A and B, and all of them are being multiplied by a constant, the first one is multiplied by a constant C, the second one is being multiplied by a constant D. then they're telling us the matrix. They multiply by the determinant second one, raise it to the dimension of that. All these properties helps us to be able to solve some problems. Solomon, your hand is up. What's your question?
Sir,
Yes.
please, your issue, and please, if you can resolve it. The network is still breaking, so please.
Okay, give me a minute. Let me change it again. Let's hope that it's better.
All right, sir.
But let's verify this. Is this breaking? Everybody experiencing it, or is individuals experiencing it?
Please, we can hear you.
We can hear you now, sir.
Okay, so okay, thank you. Okay, so these are some properties that we are properties to solve petty problems. What is a diagonal matrix? A diagonal matrix is elements outside the main diagonal that are all zeros. We'll see some examples of this. So when you have a 3 by 3 matrix, for example, the diagonal from the top left to the bottom right will all have values, but the rest of the matrix will go to 0. Then we call it a diagonal.
Please, your line is breaking.
Matrix. Okay. We are going to learn how to do what we call element. You are going to be given a system of equations. That's what today, yeah.
Hello, sir.
Hello, can you hear me? Hello.
Please, your line is breaking.
Oh, sir, we can't
Hello,
hear
can you
you.
hear me? No. I wasn't talking. No. Let's take a problem. Maybe let's take the X document, and let's follow time may help. Okay. Okay. Please, can you hear me now?
No, sir.
It's still
Breaking.
still breaking.
The MTN and vice versa.
It's okay, we can hear you.
And it's so misbehaving. Let's still continue. What if I'm going to can't do anything about this network issue?
Please, I think you should stick with MTN.
From my end. Okay, so we are going to go through the problem one by one, or you didn't hear me well. Please let me know. Is that we are going to use what we call explain in the PowerPoint row reduction method. This is actually called the Gaussian elimination method. are three things that we can do. One of them is that we can interchange rows of the matrix. We can multiply any row with a constant. Okay, I'm reading what I have here, and then we can add one row to the other. So these are the three things that is allowed in row reduction. So let's take a problem. Now let's say 3x minus 2y plus 5z. So this equation, we call the second equation minus 2 minus 1 and 4. And then the last equation, x plus 4 y minus 7z equals minus 7. So we convert this system of equation into a matrix. Okay, that's step one. Now, I think I've talked about this before, but we are going to now speak more about it from the x, y, and z. You are going to add the solutions 3 minus 2 and 1 to the right-hand side of the matrix. And that is step 2. So that is what I have done here. Sunny, your hand is up. What's your question, please?
Please, your line is breaking.
Yes, I have been told that it's happening like that. So I'm just saying that please watch from the screen. I am just going through what I have on the screen. So even if you don't hear me, just follow what I have on the screen. I'm sure hopefully my recording will be better than what you are here experiencing until end. So when I start going over the procedure and I'm still breaking, please just draw my attention. I will go over it. Okay. Because I've changed the network 2 or 3 times. It's still behaving the same way. I don't know what the reason is, but today is that bad. Okay, so Sunny, I'm sorry about that. It's if it's still persisting, I will have to give you a recording of another class to explain this to you as well. So just kindly follow. Where you don't hear me well, please draw my attention to. Let me go over that part again. Okay.
No problem.
Okay, so I'm
Yes, sir.
okay then. So okay, so now we have step 2. Now, step 3 is what a matrix. This is how a diagonal matrix looks like. Okay. This is how a diagonal matrix looks like. So we must reduce this work or this matrix or this entries so that we get something that looks like this. Okay. So how do we go about this? How do we form a diagonal matrix from a matrix or systems of equation that is given? Okay, Nathaniel, your hand is up.
Sir, please, how did we get to step 3? I think I didn't hear from step 1.
Nathaniel, I didn't hear you too.
I was asking how we got to step 3. Please, can you go a little bit back first?
Okay, we haven't done step 3. That is our aim, or that is what we intend to do. Okay, so step 3 is what I am we have to end up getting, we should be expecting. Those of you who haven't turned the things into the chat room so that you can follow. So I'm saying that step one, you form what we call the coefficient matrix. Okay. Then step two, you form what we call the augmented matrix. And then step three, we are going to reduce the rows and the columns so that we get step three. Okay, so kindly look at the chat room. I'm typing all the things I'm doing there so that if you don't hear me well, at least you can see what I'm saying. So form coefficient matrix, form the augmented matrix, and then step three, reduce the matrix so that we get something that looks like step three. Okay, so now then step four, we do what we call back substitution. We do what we call back substitution to solve for the variables x, y, and z. Okay, so all I have written so far, we haven't done it. It is now take a question. So we are going to use this question here to go through all that I'm trying to explain online. Okay, so what is our step one? Our step one is, I'm saying that now we want to solve an example two. We form the augmented matrix. Okay, so on your screen, I have formed the augmented matrix. Okay, the augmented matrix is the 1, 2, 1, 3, 5, 1, and then 2, 6, 7, and then the solution are on the right. Now, and I'm saying that we must be able to work on this matrix, reduce it so that we get this. As our goal. This is where we are going. Now, so we are taking one step at a time. The first step. So step one, you realize that row 1 and column 1 is equal to 1. Here, this one that I'm highlighting here. This value, we are saying that it is already equal to 1. And because it is equal to 1, row 1, column 1 is equal to 1, we don't do anything, I don't do anything about it because our goal is to achieve that the first row and the first entry is 1. Please kindly read, if you can't hear me, kindly read from the chat room. Column 1 is 1. So we leave,
Sir,
we leave the
please.
row 1 and do not reduce anything.
Sir, please, why are you having 1?
Okay, and it's because row 1, column 1 is the same. You see the first row, look at what you are supposed to do. The first value are your matrix. The first row, column 1. Row 1, column 1. Look at it. Column 1 in original matrix is 1. Are you okay?
Yes, sir.
I think it was right for the lecturer to end the his session and join again, because this one there is very, very terrible. I don't know how we got to this point.
Myself, I know they hear anything. I know they hear anything. Breakages is on.
Guys, kindly bear with us. The lecturer is trying to sort out the network issue. So please exercise patience. It happens once a while. It happens. It's network issue. Nobody has control over it. So please exercise patience.
Okay, we are there.
Sam Sherry, can you clarify? Can you give clarification on whether we are supposed to write our index number and name? Because we saw at the beginning of the lecture, the lecture posted a certain screen which says those partaking in this lecture should write their names and index number in full. Some people are having controversies over it. Please clarify.
It's something which is what is.
You remember the
Charlie,
lecture said,
that's
what you
that.
use for attendance is secret.
Guys.
I beg you.
Cool down. Let's concentrate on class. Let's learn first. Once we finish, we can do all this discussion. But right now, let's just exercise patience and hope that the network situation advances so that we can continue. Already now, most of us are not getting understanding. So let's just cool down. Other conversation will make us more confused. So I beg you, let's relax. Thank you so much.